Good morning, everyone. Today I'm going to tell you about the real life implementation of the mathematics, mainly in the computer science field. Today, mainly we will discuss about the cryptography. There are also many other fields in computer science like artificial intelligence and machine learning, data science. We will discuss these are the table which I have provided here is mainly telling about what are the methods from the classical to modern, what people are using to make what we're using are divided into different stages like classical, and the method we are using at this time is classical and the Vega method. And for the mathematics, we are using modular arithmetic method. Uh, Classical method or traditional method is so easy that is easy to break by the hackers, and then comes the mathematical, which is stronger than the classical method, and then comes the modern method, that is Diffie-Hellman, which is mainly used in the for the hashing purposes, or mainly for making the public and private key for secure transmission of data between the two users. So this is what we are going to discuss in today's class. Now you all are knowing about the cryptography. If we don't know about it, let's discuss about it. Cryptography. It is originated from the two Greek words, crypto plus graphene. Crypto means hidden and graphene means information. So why it is used? Cryptography is mainly to convert our plain text into the ciphertext and then again to the plain text. But why it is done? It is mainly done because the between these pipelines, whenever anyone tries to access our data, it becomes illegal. So mainly the hacker tries to access our data so that they cannot read our data. We convert it into the ciphertext. And there are various types of cryptography like symmetric key cryptography, asymmetric key cryptography, and hash functions. These are the different types of cryptography which we are going to discuss. And let me tell you brief about the cryptography. Like, here you can see the word hello. This is encrypted in the form of ciphertext. I will tell you why hello is converted into this ciphertext only and not any other. And after converting ciphertext again to hello, to only one, to only that person whom you are sending this hello, they can only access this data. No one other can access this. No one can another. No one other from that can access this text from the ciphertext. Then, like you can see here, message you have sent hello, and some mathematical computation is applied on it, and it is converted into a secret key, and it can only be opened by that person whom you sent it using that private key. Now we will going to discuss about these Caesar method and Wagner method. As in the starting, I told you there are different classical approaches which were used traditionally to uh, convert the plain text into the ciphertext so that no one another can read it in between while sending your data to the another user. So let's start with the Caesar method. Imagine you send a message hello and you don't want to others to read it. So you transform this into a ciphertext, which is now understood as Khur, Khor. Now, how this conversion takes place? Hello consists of 5 letters and Khur also consists of 5 letters. Now, if you shift H 3 times ahead, then it comes K. E again shifted 3 times, it comes H, and double L shifted 3 times comes double O. O is shifted 3 times, it comes R. So you can see that a pattern is being followed here. All the letters of the hello is shifted 3 times so that to become this ciphertext, that is cool. And this conversion of the readable data into an unreadable format, This is called encryption. And whenever the person you are sending the hello, they have some private key to unlock it. So it it takes milliseconds. इतने टाइम में हो जाता है, हाइपर टेक्स्ट तुरंत टेक्स्ट में कन्वर्ट होता है। ये जो अनरीडेबल फॉर्मेट है, इसको वापस से जब रीडेबल फॉर्मेट में हम कन्वर्ट करें, इसे डिक्रिप्शन कहते हैं। The Wagner method, as you can see, it uses keyword instead of a fish. In this method, all letters are shifted 3 times, but in this case, it uses some keyword. Like the keyword is key, and hello message consists of 5 letters, whereas key consists of 3 letters. So you have to repeat it, and you have to convert it until it becomes the it consists of a letter as much as in the hello. So here each letter is shifted differently, and the H comes on the 8th position. And when you add with the position of the K, that letter comes out to be the first letter of the ciphertext. And similarly, the position of E added with this position of E, so comes another letter of the ciphertext. And similarly with the all letters. And this way the ciphertext is formed. And this is more secure than Caesar method, because here some pattern is followed all the times, whereas in this method each letter is following different pattern. So this is more secure than Caesar, but is still breakable, because the hackers or the untrusted users uses the frequency analysis and some brute force approaches to break this. That's why it is unreliable now. Now let's move on to the second approach, that is mathematical. Yeah. Now comes the modern cryptography. In the modern cryptography, we mainly uses the mathematics. So first, starting from the mathematical modern arithmetic, that is clock maths. Like think of a clock. Here it is given a clock, and after 12 it comes 1, 2, 3. Again it goes, cycle goes on. But in the afternoon uh, you see the time is 13, then 2 is reference to be 14, 3 is reference to be 15. So you can see that 1 is equivalent to 13, 2 is equivalent to 14, and when you subtract 13 minus 1, 14 minus 2, 15 minus 3, all the numbers are divisible by 12. That's so in this way this approach is used, that some references can be taken instead of that, like 3 can be referenced as 15. So this modular arithmetic clock maths approach is used, and this is divisible by 12. So it is written as 15, 15, and equivalent to 3. And here mod 12 is written similar to this. Okay. And another comes the prime numbers. Why crypto loves primes? This is the main question. Let me give you the example. Like if you multiply 2 primes, 17 into 23, it gives you 391. And if you factorize this 391, you will get 17 and 23. But in multiplying takes less time, whereas finding the factorization of 391, we have to use the hit and trial method to find the 391. So here multiplication can be used as for the locking purposes, and factorization is used for the unlocking without the key. But you have to use the brute force approach, that is using the hit and trial method to find the exact number. Okay, here you can see the flow chart which is given here. Now comes the Euler-Tauschent function. So first of all, it is the number of integers from 1 to n that are co-prime with n, and co-prime is the जिसमें कि ग्रेटेस्ट कॉमन डिविजन या फिर HCF जिसका 1 है, तो वो होता है यूलर टोशेंट फंक्शन। ठीक है, अब जैसे एग्जांपल है n इक्वल्स टू 10 and numbers less than 10 are 1 to 9. So numbers which are co-prime with 10 are 1, 3, 7, and 9. As the Euler function, Euler totient function of 10 is 4. And from this, you can find the reference that if n equals to p into q, where p and q are primes, then the Euler totient function is given by p minus 1 into q minus 1. This is the Euler function given by. Now you can see this Euler totient function is used in the RSA algorithm. Rivest, Shamir, Adleman. This is the asymmetric cryptographic algorithm used widely for the secure data transmission. Here, we are utilizing a public key for encryption, where all can use it to make for the encrypting, that is from converting plain text into the cipher text, and then uh, using private key for the decryption, that only one can access only one can have the private key whom the data has been sent. So he can only have the access to it. So this in this way modern or modular arithmetics mathematics is used. Now comes the real cryptographic systems. Here first is the internet encryption. As you have seen that HTTPS or secure websites, they create a secure key. In this way, they do their security. And another is the question I have asked in the first, that how WhatsApp secures your data, and it is written end-to-end encrypted. So in the similar way, it create public key which encrypts the message, and it is directly sent to the server in the ciphertext format. And whenever anyone and whom you have sent the data, they have the private key to decrypt the message. So in this workflow, you can easily see it. And the blockchain and cryptocurrencies, you have seen that it is a decentralized form of it is a decentralized where the data is not centralized and all have the equal access of it. Similarly, it is used in the digital signatures of banking and documents. They create a hash of the data, private key, and others can verify using the public key. Like you have seen the digital signature on the banking documents, and if you scan it, you can verify it whether it is fake or not. So in this way, real cryptographic systems has been made. Now this is the mathematics in cryptography. So, yeah. Now comes the mathematics in cryptography. So I have told you about the end-to-end encryption, how it is used in WhatsApp, Messenger, etc. Another is the secure online banking. Like I have told you, the digital signatures are being made and others can access it using the public key. Another is the blockchain and cryptography. Digital wallets and NFTs are made, and it uses the same RSA algorithm. Password security, like you can see the hash or bicrypt form of password is generated, bicrypt or argon2. These are some of the hash functions which is used for converting the simple password into the different size or length of the password, so no one can easily access it. Secure email, it is also same way, uses some algorithm RSA and modular arithmetics to encrypt the data. Biometric security, phone unlock or face ID. In this way, the mathematics algorithms and probability theory is used by training the data. Another is the secure internet browsing. Like I have told you about the HTTPS, how they secure the websites. And
The other fields which I have told you, I will give you the overview, are the game development. They uses linear algebra, vectors, and mathematics, like where the player can move in which direction, how their moves are decided, and um, using matrices. Another is the artificial intelligence and machine learning. In this, you have to learn about the different algorithms and you have to train your model according to it. They uses the mathematical approaches and algorithms to train the data. And data science analytics, this is the most demanding field. And here you have to deal about the probability and statistics of the mathematics. To understand this, another is the networking and internet. These are some of the real life implementations of the mathematics which I told you as far as I know. And thank you for giving your precious time. I hope you have enjoyed it.